Hello everyone, welcome to my channel. Today's topic is Poisson's distribution. Now, when to use Poisson distribution? In case of binomial distribution, if n and p are known, then we can find probability. In case when n is very large and p is very small, then in binomial distribution, calculation becomes difficult. In that case, we have to use Poisson distribution. In Poisson distribution, for x is equal to r, probability is equal to e raised to minus m raised to r upon r factorial, where m is mean and mean is equal to n into p, or mu later is also used. Lambda is also used, but I am using m here. Now let us solve some. Question is, if the probability of bad reaction from a certain injection is 0.001, determine the chance that out of 2000 individuals, more than 2 will get a bad reaction. Now, probability small p is 0.001, very small number, and n is 2000. Now, mean m is equal to n into p is equal to 0.001 into 2000 is equal to p into n is equal to 2. Now, probability that more than 2 probability that more than 2 will get bad reaction is equal to p r strictly greater than 2, means 3, 4, 5, 6, 7 up to 2000. Is equal to 1 minus, but p for x is equal to r is e raised to minus m raised to r upon r factorial. Therefore, x is for r is equal to 0, e raised to minus m is 2, m raised to r is 0 divided by 0 factorial, plus e raised to minus m raised to upon r factorial. Here r is 1 and m is 2 plus e raised to minus 2, 2 raised to 2. M is 2 and r is also 2 divided by 2 factorial is equal to 1 minus e raised to minus 2. Any number raised to 0 is 1 and 0 factorial is 1 plus e raised to minus 2 into 2 plus, now 2 into 2 is 2 square is 4 into e raised to minus 2 and 2 factorial is 2 into 1, that is 2. Is equal to 1 minus e raised to minus 2 plus 2 e raised to minus 2 plus 2 e raised to minus, this will get cancelled and 2 e raised to minus 2 will remain. Okay, is equal to 1 minus 5 e raised to minus 2, and this can be written 1 minus 5 e raised to 2. E raised to minus 2 will be divided by, right, e raised to plus 2. 1 minus 5 e raised to 2 is given in the sum 7.4. Now if we solve this using calci, then answer is answer is 0.3243. Let us solve one more sum. Question is, if 5% of the electric bulbs manufactured by a company are defective, use Poisson's distribution to find that probability that in the sample of 100 bulbs, first is none is defective and second 5 bulbs are defective. Value of e raised to minus 5 is given 0.007. Now 5% electric bulbs are defective. Therefore, small p is equal to 5% means 5 upon 100 is equal to 0.05. P is small. Now n is 100 bulbs, sample of 100 bulbs. Therefore, n is 100. Now mean n into p is equal to 100 into 0.05 is equal to 5. Now first is probability that none is defective. No bulb is defective is equal to, now formula is probability for x is equal to r is e raised to minus m, m raised to r upon r factorial. Therefore, probability that no bulb is defective is equal to probability for x is equal r is equal to 0. R is equal to 0 is equal to e raised to minus m is 5. 5 raised to 0 divided by 0 factorial is equal to e raised to minus 5. Any number raised to 0 is 1 and 0 factorial is 1 is equal to e raised to minus 5, and this value is given 0.007. Therefore, probability that none of the bulb is defective is 0.007. Now, second is 5 bulbs are defective. Probability that 5 bulbs are defective is equal to the probability for r is equal to 5. Formula is e raised to minus m raised to r upon r factorial is equal to e raised to minus 5, m is 5, 5 raised to r is also 5 divided by 5 factorial is equal to e raised to minus 5, 5 raised to 5 divided by 5 factorial is 5 into 4 into 3 into 2 into 1. And this value is given 0.007. E raised to minus 5 is given 0.007 into 5 raised to 5 divided by 5 into 4 into 3 into 2. And if we simplify this using calc, then this is equal to 0.1823. Probability that 5 bulbs are defective is 0.1823. If you like this, then please like, share and subscribe and comment. Thank you.